right, it is 10 o'clock. We're still admitting some people in, but for those of you who are still joining us, welcome to Stormwater Awareness Week and welcome to the Protecting Creek Water Quality During Construction workshop. Rob and Tully will be presenting for us today from Tully Consulting Group. So, Robin, if you'd like to introduce yourself, we can get started.
All right. My name is Robin Tully. I'm a civil engineer. I graduated from Humboldt State in 2000, and I've been doing stormwater stuff ever since in some fashion. Started out with a civil engineering company doing water, wastewater, and stormwater designs like detention ponds and conveyance systems. Then got into sweepy. I've been doing the 2009 CGP and 2022 CGP, writing SWIPs and monitoring and inspection, regular weekly inspection, sampling, and all that since the permits came about. So I really got full time deep into just SWIP in 2011. So been doing this for a while, and we love what we do. It's been super fun. We work with a lot of great contractors and some cities and counties directly. And so today I just wanted to share some things from our past experience and have a lot of fun pictures. So I'm really picture heavy. That's how I learn. A picture's worth 1,000 words. So I'll do a little bit of talking in the beginning in terms of slides, reading from slides. And then probably like like when we get kind of done with that, then the second half is just all some cool photos. So thank you for joining. Feel free to ask questions. Gabrielle is going to moderate. So if you have a question that pops up during something that's relevant to what I'm talking about, feel free to put it in the chat and she can bring it up because I don't have the chat open. All right. So we're specifically talking about work in or near waterways. This is mostly in waterways. So some applicable permits that come into play. You have your 401 water quality certifications. Oftentimes, our jobs also have a Fish and Wildlife Streambed Alteration Agreement, a 404 Army Corps permit sometimes, or a nationwide Army Corps 14 permit. And of course, the Construction Stormwater General Permit for sites over 1 acre of disturbed soil area. Some of our jobs sometimes, if they're really sensitive, they might have a NOAA fisheries biological opinion. The federal agencies must consult with NOAA fisheries on activities that may affect ESA listed species. Or there may be also local or regional flood control or irrigation permits we're also abiding by. Depends on the water body, whether we have a waters of the state receiving water, or sometimes we might have an irrigation canal. So the 401 water quality certifications, I'll just kind of recap this a little bit because I'm assuming everyone here probably knows about what this is. 401 water quality certifications apply to waters of the state. They protect beneficial uses as defined in each of the Water Quality Control Board basin plans, and there's a link. So if you have a creek that you're needing more information about, look at the basin plans for the area that the regional board that you're in, and you can do a search in that document for that creek. Sometimes it'll come up, or sometimes it's just within that a larger watershed. So, but check out the basin plans. They're really helpful. You refer to the water quality objectives in each basin plan. Review carefully for monitoring and reporting requirements. See a sample 401 permit that I have included later just as a guide for where some of this creek monitoring provisions are coming from. Monitoring for some 401s is required upstream and downstream during in water work. Anytime you have a plume or some pollutant reaching that water, and some of them even say during the diversion operation. So just a heads up, it's not always just during your in water work. Sometimes it can be the entire time a diversion is in operation, especially in the Central Valley Regional Water Quality Control Board. I'm definitely seeing that in their 401 permits lately. What are waters of the state? They can be tributaries, intermittent streams, like those blue line streams that show up on the USGS quad maps. They can be obvious creeks and rivers. It can be the bay, it can be the ocean. So again, sometimes, they can be obvious, and they mostly are, creeks, rivers, and bays. But sometimes they can also be not so obvious, like a dry drainage ditch running through the project that you wouldn't maybe think about that. being a 401 area or waters of the state. But if it ultimately discharges into a waterway, even close by or sometimes somewhere a few miles away, they can still be deemed waters of the state. So you have to be very, very careful. Just um, don't assume just because it doesn't necessarily look like a creek that it isn't waters of the state. Usually they do have a defined bed bank and channel, but sometimes that can be hard to see. I do want to talk about temporary creek diversions. A big part of this is how to keep water clean during construction. And a lot of times that's going to require some kind of temporary creek diversion. So I want to talk about that first and tell you kind of what some typical types are and then some typical problems to look for, and some good tips too. So first off, there's pumped systems. Those are fairly expensive because you're going to have a lot of fuel costs, keeping those pump systems maintained. And then there's some biological considerations because you want to make sure they're appropriately fitted with fish screens and you're not sucking up fish into your pump system. The other thing is someone's going to have to monitor them, pretty much 24/7. So they're pretty involved. The second type, the most probably common type that we see, gravel bed cofferdams and temporary culverts. So those are your gravity drainage pipes. And I've got some good pictures. Another type is bladder dams with temporary culverts. We don't see those that often because they are expensive and there's a time and place to use them. You can't use them in rocky areas. You just aren't getting a good seal. But if you have bigger waterways and really sandy bottoms, they can be great alternatives. So we have used them successfully, and sometimes not successfully. So I've got some cool pictures for you. Sheet pile cofferdams, those are great when you have non-rocky conditions and maybe you just need to sheet pile off maybe just part of the bank of a large river. Large rivers, you're not going to be able to get a gravel bed cofferdam into. Just isn't hydraulically going to work. It's probably cost prohibitive. And so a lot of times that's when we're using sheet piles as a larger river or a creek. And then another one would be a lined channel. And I've got a picture of that. So let's first talk about pumped systems. So a pump system is where for some reason, maybe there's just not a good opportunity for a gravity system. It's flowing enough. Maybe they were having troubles getting it into a gravity system, or the work area just isn't conducive to putting a pipe through it. Maybe you have to tear that whole thing up, and there's just no way to keep a pipe running through it that's gravity fed. So sometimes people have to do pump systems, and setting those up is costly because you're going to have a generator somewhere that needs fuel. You're going to have to constantly feed it fuel. You're going to have somebody there watching it, or at least able to check on it. Like let's say at night or on weekends, the pump shunts off. You don't want that water backing up, going over your cofferdams and getting into your work area. So you got to have somebody dedicated to watch that system. It can be costly, $500 a day for gas. Fuel's expensive, whether it's diesel or gas. So we don't see these that often. If you can do a gravity system, gravity's always best. So, but sometimes there's a need for them. So that's what one would look like. I do have another picture later. But anyway, I think this was up on one of the forks of the Cosumnes, and the picture at the right shows they were outletting it downstream into a part of the side channel that then went back into the river. So it was a very clean system. We didn't have any issues. The only thing, of course, was just keeping it running, feeding that generator. This is the most common type you're going to see: gravel bed cofferdams and temporary culverts. The cofferdam, it's either made of small gravel bags inside of it. The whole thing's wrapped in plastic. Or sometimes, if you have larger ones, you can use those super sacks filled with clean gravel. So the 3x3x3 foot bags are really handy because you can really build up big cofferdams. This one here has a gravity pipe going in between. So the nice part is once it was running, it didn't require a pump. Water went through clean, nice. It leaked a little bit. We could tweak. We'll talk about that. But anyway, it was a really nice system. And those are generally, once you get them in, they're going to be the easiest to maintain. Here's another example of a gravel bed cofferdam and temporary culvert. That's this particular one was an upstream culvert. This one did leak. We had a really rocky bottom. They were trying some different things to try to get that sealed. But they were so rocky underneath, they actually had fish coming underneath somehow. I have no idea, getting into the work area from rocks below. But we'll talk about some ways that we can help get those sealed better. A bladder dam and temporary culvert, that is a pretty large bladder dam. This particular channel, this was in Vacaville. I think this was Alamo Creek. It had a fairly sandy bottom, or sorry, non-rocky bottom, so that they could get a good seal. It actually did work pretty well. This picture was before some dewatering. So there's still some water in the channel, but I do have some other pictures. So this was pretty successful, although I'll show you a picture of what happened when it got vandalized. So pros and cons. A sheep haul cofferdam. This was at the Russian River for a fish hatchery, a fish ladder, sorry. This is a really large one going in. As you see, they still had an opening there. They were finishing that up. And then they put some dewatering groundwater wells on the inside to keep it dry on the inside. But the nice part about this was it only closed off half the channel so that the rest of the flow in the river could go through unimpeded. That's very important, especially when you have a large river. The last type that we've seen is a line channel. And this was when someone just needed to kind of divert into half of the channel. And so they actually they had ability in their permit to do this. They made a line channel off to the side so that they could work on the channel on the other side. So the nice part about this is it was gravity flow also, it was pretty low maintenance. We actually never had any issues, even though it's pretty simple. But anyway, some tips for success. So plan ahead, have a good diversion plan. That's important. Get somebody that's experienced. Some of those have to be stamped by a civil engineer. And then have a good conversation between all the parties, the contractor, the superintendent, the permittee. Caltrans, for example, has an environmental liaison. And then of course you're a good SWIP person, good civil engineer. I'm a QSD and a PE, so that helps me when writing diversion plans, that experience. Estimate the water flow anticipated. That is important. You want it to be at the lowest part of the season, ideally. You're not designing diversions for the wintertime. Generally, that's going to be too much water, and it's not really going to be very realistic. Let's say you're replacing a box culvert or bridge that has 100-year flow of like 1,000 CFS. You're not going to be able to do a diversion for that unless you just have some kind of cofferdam off to the side or something. You're not going to have a gravity pipe diversion that's that much flow. A lot of the times we're dealing with stuff that's 10 CFS or less. That's more realistic. And again, we're just doing this in the dry season when those anticipated water flows are the least. That's your best time to do these. Put in your downstream controls first. Maybe you're going to have a silt fence or a turbidity curtain. It's not always appropriate to have silt fence across the stream. Turbidity curtains are, I think, a little more effective, although they're not perfectly effective either, but you want to have something in place. And then the big one, you're getting ready to do a diversion, checking the time. Order your materials ahead of time and have extra supplies on hand, pipe, gravel bags, plastic, your pumps, if you're using pumps or your sump pumps, your buckets, your rock to put those sump pumps in, clean gravel, your silt fence or your turbidity curtain. The more you have there ahead of time, so that if you have any issues or surprises, you're gonna have the materials there to take care of it. We've had it where we show up at a job site, the contractor shows up, they think they thought they had it together, but something happened, their pump didn't show up. It happens all the time. So your best plans get laid aside, but it's very expensive to have the biologist there, to have us there do the monitoring. So maybe take some dry runs, go out, get all your supplies, take a look at it, kind of anticipate some problems and, get more supplies. But the more you have there ready to go, the better. If you've had diversions take a day, more than not, they're taking 3 to 5 days. We've even had some take a couple weeks by the time you fix the issues and get the dewatering down. So the more water you have, flowing in that channel, and the more rocks, generally the more issues you're going to have. So I just can't stress enough, have extra supplies. Um, Tips for success: a key trench under the upstream cofferdam lined with plastic is often very important. Sometimes they're not going to want you to dig that, but it can be good. Digging a 1 to 2 foot key trench on the upstream cofferdam will help so that you can line it with plastic, line it with gravel bags or clean pea gravel. And then that really helps to get a seal underneath your cofferdam, because especially if you've got rocky conditions, you can get a lot of seepage underneath that cofferdam, and that water is going to enter your work area and cause issues. That's a lot of the most troubles that we have, that we see, are just leaking cofferdams and leaking water into your job site. So you want to avoid dirt or fine material if you can in your cofferdams or your temporary crossings. You want to avoid the white photodegradable bags. They do break down easy in the sunlight. You want to dig out rocks to get a good seal. You want to have a downstream cofferdam, ideally, because that, if you have any kind of issue that happens inside, your downstream cofferdam is going to catch that and keep it to your work area before any kind of water it gets downstream. So you probably are going to have some kind of pump to dewater the interior, a small sump pump at least for some of the water that gets trapped inside that you need to dewater and dry out your work area. A baker tank if needed for handling that interior water. And you want to remove water before winter, weigh down your pipes, and in case you had some kind of issue foreseeing some flood in there. Ideally, you're not putting this in the winter to create yourself in or get yourself into that situation. But anyway, some common diversion problems. Let me check the time. 10:16. Okay, we're doing good actually. Common diversion problems: lack of a key trench upstream. This one here, I don't think it had a key trench, but it also was very rocky, so that it was leaking underneath. You can have leaks in the cofferdam itself, or the pipes. Failed pumps, failed bladder dams, flash floods. Those do happen. We've had floods some flash flooding, weird thunderstorms in August even. September, definitely start getting them up in the mountains. It can happen. High velocity water moving through pipes or gravel bags, that can cause issues, cause your pipes to separate or gravel bags to move. Groundwater intrusion, that's pretty common. You can have backwatering from downstream. So definitely that's why you want to have that downstream cofferdam as well. If you're in a really flat channel like out in the delta with limited slope, you will get backwatering. Sometimes you can have undersized cofferdams or pipes. Maybe you size them for the flow you think you're going to have, and then somebody upstream lets out some irrigation water, and then all of a sudden you got a wall of water coming down you didn't expect. So definitely keeping pipes amply sized. Factors of safety. Don't try a 12-inch pipe. Think about 24, 36, 248s. Depends on how much flow you have. There are flow sizing calculators. Unknown irrigation flows. Yep, that's definitely happened before. This is a picture of an example of it was one where that upstream cofferdam, they were having trouble getting a good seal on it. And there was water coming into the into the work area. So that was definitely causing some issues. They can pump that out, try to mitigate it. But that's just sometimes what some of the issues that you have with diversions. And sometimes they're just hard to get a good seal. Really rocky terrain, it can be really tough, but definitely you want to try to dewater that work area as much as possible, fix leaks, address that issue, have sump pumps if you need it, because the drier that is, the less issues you have of causing pollution and also the water just getting in the way of your work. So I definitely want to talk about this because diversions and work in creeks, it's very sensitive work, and no matter sometimes of your best intentions, stuff can happen. So this was the bladder dam, actually got vandalized. Somebody came and just punctured it with a knife. That was really, really unusual. So that can happen. So this was not a planned thing. This bladder dam blew out because of vandalism. And then, the channel was very flat, so the water backwatered up into the work area and caused all sorts of issues. So sometimes stuff happens. What do you do? Have a plan. So this is where experience comes in. You definitely want to get have some help. If you aren't experienced, grab somebody that is, because this is where that is really important. Stop the in-water work. If there was some activity that was causing it, maybe some trenching in the middle that was causing some groundwater, and then that groundwater was getting out, and the groundwater was turbid or something, stop that work. Figure out what the exceedance was caused by. Assess the source of the leak or the plume, and then contain the water. Pump it out into a water truck. Get it out of the creek. Contain it and ideally get it out of there. Add BMPs for downstream controls, such as maybe you need a bigger gravel bed cofferdam. Maybe temporarily some silt fence. We're not really using that much anymore, but there's sometimes on slow moving stuff, we've used silt fence because it was all we had. And at least it slowed the water down to contain the turbidity. Turbidity curtains are great. I've got a great picture for you where they were applied and they worked really well. You want to notify your resident engineer, notify your QSP or your project manager, notify the water board within 24 hours. Usually that's spelled out in your permits, and the permittee is going to do that. That's very sensitive information going out there. So definitely that should be the permittee that's getting notified and notifying the water board. And then you want to reevaluate your additional BMPs. Take that time to figure out, like, what else do you need before getting back in the water and resuming the operations. And talk with a contractor. Let's say you're the one monitoring this. Maybe you're monitoring the upstream and downstream for the 401 permit. Talk to the contractor and have a good conversation about what can be done, and have that plan ahead of time before getting back in the water. The water board, they just want to be notified. They may come out. I have had them come out when they're notified, and then it's just better, that open line of communication, like, hey, something happened. We didn't mean for it to happen. We're going to fix it. And the upfront communication is just better for everybody. I've never, mark my words, I don't want this ever to happen, but I've never had an issue with or got a fine by self-reporting something. Good housekeeping. So I do want to talk about this because good housekeeping goes a long way to keeping waterways clean. It's not just always the big stuff. Okay, the diversion's the big one, but the rest of it really is just good housekeeping. So put chemicals in covered secondary containment when not in use. So there's a picture of a secondary containment. Have self-closing locking gas cans that are UL certified. Keep chemicals ideally out of the creek area, although we know sometimes you got to have them in there. You're fueling something up, maybe you're fueling a generator up, so you had your gas can in there, but try to, when it's not in use, put it back in a Conex container or put it back in the foreman's truck, or some other secondary containment. Have a spill kit on site at all times. Have a good one, not just a bag of kitty litter. Have a good 30-gallon or 50-gallon spill kit that has a lot of BMP supplies. That can help you contain the spill. That container then also is able to hold some of the spilled material, let's say spilled oil. Take the spill absorbents out of that spill kit, use that spill kit container for holding that material until you can get it hauled out and figured out. Put waste in covered containers. Pick up daily. Some of your wildlife or some of your fishing game permits will tell you to do that, because you don't want to encourage wildlife to come down and eat like your lunch, your leftover lunch sandwich or wrapper. That can actually hurt wildlife if they're chewing on plastic. So just make sure picking up waste is a good thing to do daily. Have secondary containment under generators and stationary equipment. So this is like for your cranes or your generator, or any other equipment that you had to have down there. Conduct fueling out of the creek area. We'll talk about the permits. 1024. I'll talk about the permits a little bit, because sometimes it's in your fish and wildlife permits. Other good housekeeping and other measures: keep work areas clean. Add erosion control where needed for inactive areas or for rain. Locate your generators and other equipment ideally out of the creek area and on level ground if you can. This was actually a pretty big pump system. This was 2 8-inch pumps. We had quite a bit of water. There was 11 CFS we estimated coming down. They were doing quite well, but eventually they were able to talk to the regulator, and in this case, this was coming from a lake, and the lake was able to divert it somewhere else completely, which actually helped. Watch your creek work windows. Example, very typical, June 15th to October 15th are typical work windows. You're going to look at like your CDFW permits are going to have a lot of work window criteria, not being in there in the rains, and certainly not being there past October 15th. Sometimes it's hard if you're up in the mountains and you have a lot of snow melt runoff. Maybe you're not able to get in there June 15th. Maybe you're waiting till July, sometimes even August, because you're still getting snow melt. So sometimes you don't have the luxury of getting in when you can. But if you have that luxury, schedule. Get in as early as you can within your work window so that you can get out on time. Because a lot of diversions, when we see issues, it's you're getting into the rainy season and maybe they got an extension to go past October 15th, and now we're all sweating bullets because rain's teetering on the forecast, and everyone's scrambling trying to get work done and get out of there before your work window closes. So that's the scariest time for me, is when diversions are in October or going past that work window because they've got an extension, and it's a scary time for all of us. Rain is not always coming in the right amounts. It's either not coming or it's coming big, and oh crap. Other BMP measures. This one's very important. If you are going to be doing a lot of crossing across that channel and you have to restore that creek later, you want to make sure, one, that you're allowed to do that in your permit. Don't only disturb what you need as far as what you need to do for construction and what is in the plans and permits. Don't go outside of that. Any activity beyond that or different than what was written in a permit requires modifying that permit. So just read those very carefully, know what's in your permit, know exactly where you're allowed to disturb and where you're not. If you are restoring that creek channel, or maybe you're putting riprap, okay, then maybe you're going to be able to destroy that channel during the work because you have to, because you're going to get riprap in there. But if you're not, put some filter fabric or plastic over the creek bed. Then add your BMPs on top of that. This one had actually a layer of material below this. Then it had some rock material. Then it had a layer of plastic, and then the pipe was on top of that, and then the rock was on top of that. That's so that later, when they're done with their false work and their bridge, they're taking all those BMPs out. Then they're getting down to that last layer of plastic or filter fabric. They pull it up, and boom, the channel's there. It's somewhat disturbed. It's compacted, but at least it hasn't been damaged and completely altered. So just be careful of that. Dewatering. Dewatering becomes necessary because you want to keep the work area dry and prevent contact with water and cement or sources of turbidity that could get downstream. A little bit of water, that's normal. You can pump that out and dewater it. A lot of water coming in, that's a bigger issue, where you're going to want to really look at your upstream cofferdam and your pipe joints and deal with that, so you can prevent as much water coming in as you can. But a little bit of groundwater and seepage water, that is normal. So sometimes dewatering is needed. I'm doing okay on time, 10:38. So I want to talk about a little bit more about some examples. Dewatering. So this was a dewatering sump within the work area. So they had their diversion pipe going through. That was the picture before. So they had their diversion pipe carrying most of the water through from the upstream to the downstream. So that was an excellent one. And then they had some ancillary seepage coming in from the ground, and they needed some dewatering sumps. So very, very typical. Baker tanks can be useful for collecting the dewatering. In this case, this was going into a baker tank, and that allowed them to help settle the material. If they needed filtration, they could add filters and whatnot to this system. And this was also a way to contain the water if the pH or the turbidity is not acceptable for discharge. So it goes into the baker tank. You test the pH and turbidity or other parameters in your 401 permit or your Caltrans specs. And then, if it's acceptable, then okay, good, you're discharging. Dewatering bags can be useful to help alleviate the water to upland areas. So in this is that same example. They were testing for pH and turbidity, and then They were letting it go out of dewatering bag. Don't rely on the dewatering bag for a lot of turbidity control, because if you have a lot of sediment, it's going to plug that bag up, and then it can burst. There can be other issues. So use the dewatering bag with relatively clean water. Test daily for pH and turbidity or other parameters in accordance with the 401 permit, or maybe you have attachment J dewatering of the new CGP, or other approved dewatering permit. Now attachment J in the construction general permit is nice. It just says you can use attachment J provided that no other permit is in place. So you got to know what area you're in, what other dewatering permits apply. And John Dravskis had a great flyer on that. He's got some great summary sheets of what other permits might come into play depending on what water board region you're in. So thank you, John. That's awesome. Dewatering bags can clog easily. Again, I just want to point that out. So be very careful if you're using them. You don't have to use them if you have clean water. And then have scour protection too. So maybe you want to have some riprap or some gravel bags at your dewatering outlet. Be very careful about diverting too much water when dewatering. I had this one come up. Normally we think about, oh crap, any kind of water that's in that diversion area, we don't want to put that back in the creek. We want to get it out of there. Well, I had to kind of rethink that because this particular job was getting a lot of leakage. So this was creek water coming into the job site. And at first it sounded like a good idea. Let's put it out in this field. But what happened, it really was just too much water being diverted, and it was taking water away from the natural creek flow. And so we talked about it, and we decided, between, Caltrans and the contractor and the environmental liaison and I, we came up with a better plan, and the contractor was able to go back in and do some fixes. I'll talk about that on the next slide. But what I want to talk about here is just make sure that you have your appropriate dewatering permits, whether you're following attachment J, whether you're following a 401 permit. Maybe you had some dewatering that was going to an MS4, so you had to reach out to the local MS4, city or county. Or maybe, you're in the Central Valley region and you have a low threat discharge to land permit. Just follow the appropriate permit parameters. We're probably going to have some testing involved and some permit conditions. This particular example, because again, we were diverting a little bit too much water, and that was taken out of the creek flow. The contractor went in and really redid a lot of stuff. They fixed their leaking pipe joints, and redid their upstream cofferdam, and that helped tremendously. So here's a picture of dry conditions. And this significantly reduced the water getting into the work area that we had to do or getting into the work area that we had to deal with. This is what the upstream looked like. They redid that cofferdam, and really rocky terrain, so it just was having some issues getting a good seal. And then they added dewatering pumps right behind the upstream cofferdam to get the clean seepage water before it reached the work area. And I can't remember in this case, but I thought they had a second dam down, like just immediately downstream, so it kind of made this little trapped area where they were pumping the water that was still seeping beneath the cofferdam, because this was a lot of water. So, but anyway, that water though was clean, and so we just pumped it right back upstream into the creek, and then it went in through the diversion pipe, so that it went cleanly through the job site. And then we weren't taking that water out of the creek system. So this was just the seepage, real clean seepage water. It wasn't coming into contact with any construction. So this was just an option, because sometimes we do have to do this. You do have to deal with some groundwater seepage or creek seepage, but you want to keep that water, if it's clean, keep it back in the creek, because that water is needed for fish and wildlife. 1033. Let's talk about a 401 permit example. Here's one. This was Port of Stockton Navy Drive Bridge replacement. So this was, I actually really like the Central Valley Regional Board 401 permits, because they're very clear about when we need to sample and what we're sampling for. So here's what one looked like. Turbidity, they wanted every 4 hours during your in-water work. Settleable material, that was a lab test. And then visually, continuous throughout the construction period, you're looking for visual pollutants. Do you have any sheens, or can I visually see the turbidity? In this particular one, we were also sampling for pH every 4 hours. Beware Caltrans. If you're on a Caltrans job, they're going to take this and they're going to up it. and they're going to want you to sample 4 times a day, not just every four hours. So look at what's most stringent and look at your 401 permit and look at the Caltrans requirements if you have a Caltrans job, and you want to make sure you're following the most stringent. More times, often than not, it's the Caltrans spec, but not always. Sometimes their spec writer might miss something in the 401 permit. This particular 401 permit said this, you want to sample your surface water at mid depth, so you're not just pulling from the top. That might be cleaner. And then you want to submit a surface water monitoring report. This one, it wanted it every 2 weeks. Caltrans jobs, they have it, you're only doing assembling your reports into a monthly report once a month. But in this older example of a 401, the water board wanted to see something every 2 weeks. This particular permit, this was the limits for the turbidity. They had a kind of a graduated table where if your upstream turbidity was 1, your downstream could only be 2 NTU. So be careful when you're working in a creek because your turbidity limits are very, very, very limited. If you have very clean water upstream, that's, oftentimes 1 NTU or less, you're only going to have the ability to go to 2 NTU downstream. So you have to be very careful when you're working in a creek. Even out in the Delta, the San Joaquin River, I thought, wow, that looks terrible. It's got to be 400. No, we took a sample and it just looks turbid, but it wasn't turbid as you'd think, and it was like only 40 NTU. So be careful with that. pH cannot be outside of 6.5 to 8.5. That's very, very typical for a lot of water quality objectives. 1036. All right. I want to bring up a CDFW, streambed alteration agreement example, because it's really interesting. You'd think all your requirements are going to be in the 401 permit for your waterway, but no, there's actually a lot more restrictions that apply to us in the CDFW permit. So be careful of that. Read those very carefully. That's where you're going to see your work windows. That's also where you're going to see stronger language about not working in that receiving water within days of rain. So this one was some tributaries to the Yuba River, and this is a typical CDFW type wording where it said anytime there was a 1/4 inch of rain in a 24-hour forecast, we couldn't be in the water, or anytime the rain was over 50%. And then there was a dry out period too. They want 24 hours after it rains before you can get back in that channel. So just be aware of that. Read all your permits. An on-site biologist. So a lot of times, we're joining up with a biologist. Maybe Caltrans has a supplied one, or maybe the contractor has to supply one as part of their contract. So the biologist needs to be there, especially before the diversion goes in, because they're going to be looking at that waterway, making sure there's no species that have to be relocated. Okay. This is just more to look at in your CDFW permit. It talked about not fueling, in that waterway area if you can. Talks about where they want you to locate your staging area. They want that up and away from that creek bank and the habitat, and other requirements. We even had a job where we had to decontaminate equipment between zones. So that was kind of interesting. So take a look at that. All right, now, yay, I'm down to pictures. All right, so for the rest of the time, we just have some really good picture examples for you. And I'll kind of go through these. So this one was that bladder dam. This was Jepson Parkway in Alamo Creek many years ago, and the contractor did a fabulous job with that. That is setting up. They were setting up the bladder dam. They're working on the bridge, and so a lot of times when you're doing a new bridge or widening it, you need that diversion. So this is a bladder dam, coffer dam going in. They're putting it across the channel. They're starting to fill it up with water. And boom, there you go. There's their bladder dam. So, and then they buttress it up with some super sacks, and then they I think that was existing water line going across. So you can ignore that blue water line. That was not part of the project, I don't think. Turbidity curtains. So these are only really effective in like slow moving water. Don't try to use them in fast moving water. They're not really going to work. This particular one was at Jepson Parkway, and the water was a little bit turbid. This was during the diversion installation, and it's normal to have some turbidity. You got to dig your key trench in, disturb the channel bottom a little bit. So a little bit of turbidity is normal. But these 3 staggered turbidity curtains, that's the best application of turbidity curtains I have ever seen. And it was just doing a phenomenal job. By the time it got to that 3rd turbidity curtain, there was no turbidity. This was slow moving water, so that is the caveat. These are really effective in slow moving water, not so much in fast moving water. Just another picture of that bladder dam going in, and the diversion pipes running through. And then that was, I think that was the upstream part, so where they were getting the water in. Another example, I kind of wanted to also hit on a couple creek restoration jobs so you can see some cool work going on. There's been a lot of money put into that with different agencies doing some creek restoration work, and it's really cool to see. This had a sheet pile cofferdam, so they're blocking the river out because they were working inside to create some floodway channels. 1040. This is what that looked like when they weren't quite done yet, but they were done enough that they were putting it to bed for the winter, and they had it stabilized with some netting on the sides. And so this was an extra floodway channel that they made so that if the creek gets high and needs to flood, that it has somewhere to flood instead of flooding the vineyards nearby. It was going into this floodway channel. So it was pretty cool. So that was, I think, in March of 2024. And then I came back later that year, actually just about a month ago, and this is what it looks like now. And a lot of that vegetation has grown. They're still not done with this one. I think they do have some places they need to go add some additional vegetation. They're going to add some willows, for example. But this is a really neat creek restoration, floodway channel that they created, and the designer had them put in like some logs. They're just trying to create little habitat areas. And areas for where the water can kind of slow down. Yeah, a little habitat enhancement. It's pretty neat. And that was where the water comes in from the main channel. They had these little logs. That was in the design. That's a design thing. It's not just randomly tossed there. This was another Dry Creek example, Dry Creek Phase 4 Site 13B. This one was a little narrower channel, and you can see what they're trying to do, creating that kind of meandering channel habitat kind of thing. It was kind of neat. This one wasn't finished yet. I think this one also got some willow plantings, so I should go back and get some really cool post pictures. Another one, this was Foss Creek Pathway, segments 7 and 8. This was I think this was Healdsburg. Anyway, this is like I think it's a creek floodway channel. This is not obviously the actual creek. But they created this nice little meandering pathway off to the side. It's really cool. And then this huge flood channel off to the side. And then this is what the finished pathway looked like, more outside of the creek area. But I thought it was really cool. You can actually go stay in downtown Healdsburg and walk that pathway. Napa County has done a ton of Napa River restoration type projects. They create these little flood channels off to the side to give these little, again, like these little meandering floodway channels. And then they go through and vegetate them, and they come out pretty cool. We've done, I think, 3 or 4 of these now. This one was Napa River Oak Knoll Reach Group D, also next to a cool winery that was kind of fun to think about stopping at. And this is what that floodway channel looked like. So this is not the Napa River itself. This is this little side flood channel, but it's pretty cool. This was I think taken in about September actually. So this was only one season after this had the vegetation been implemented. It was actually doing really well. I think that was one winter of growth there. It's going to look even better as the years come. So anyway, it's pretty neat. Another really cool example, this was Geysers Road Bridge. This was a really, really good diversion and Temporary Creek crossing, and they protected that channel again with lining it with plastic underneath. 1044. This was what I believe this was the upstream cofferdam. So they had that super sack cofferdam and it was wrapped in plastic. And they were getting a little bit of seepage just because this channel is really rocky, but that's why they had the rock underneath so that the water could kind of travel through that rock a little bit without contacting dirt. They did have some dewatering set up to help as well. And that's what the downstream looked like. So the work area was really completely cut off from the creek connectivity. And so the water was flowing through that pipe, and that's what the downstream looked like. So really, really nice setup, actually. I was pretty impressed. This is another example. This is when you have a large waterway that you can't do a gravity full-on diversion across the whole waterway. This is when you're working on the side bank and you just need to contain that side bank, and the rest of the water was flowing in the channel normal. So they're putting riprap on the side channel, so they had to dig out all the way down to that waterway. So wow, what are you going to do? You can't put silt fence down there because your silt fence would be in the water and also in their way. So the only thing that we could do here, and it actually worked really well, was a turbidity curtain. And this contractor just really, really was diligent about being careful when they were digging, making sure that they're not causing a plume and that they're only digging what they need to dig. And then, there they are putting their rock riprap back in. So this was an outstanding job. This is looking at one of the anchors. So if you have a turbidity curtain, you want to have something to hold that in place. So in this case, they had these concrete blocks, and that turbidity curtain was anchored on both ends with concrete blocks. So I thought that was a really awesome example. I was pretty proud of these guys. Other things that these guys did, they had their secondary containment there for their chemicals. They had a spill kit. And then that secondary containment bag down below was useful for anything else that may have come up, like a chemical that they needed to set in there or concrete or whatever. So I just thought they were doing a really good job. We 10:46, we're doing good on time. So this is a really cool example. This is one we did probably 7 years ago. Really probably one of the biggest ones we've ever had to do in terms of some kind of diversion structure. This was the Russian River fish ladder, and this was over in a place called Mirabel. So this was pretty intense. So they had this sheet pile cofferdam. Here they were doing, I think they had they kind of make mini lakes up there sometimes. And they were doing some work here. I can't remember what this was as part of the fish ladder, because I do have other slides of where the fish ladder was, but there was some ancillary work going on upstream, and they had created this whole side channel. This is a big deal. This was a big deal. So that's just looking downstream, using our drone and getting some cool pictures of that diversion. Then further downstream, this was where the fish ladder is now. But you can tell, like, oh wow, that's a big river, and you gotta have some serious planning ahead to do this one. So this was pretty neat. This was where they created a sheet pile cofferdam along the side where that fish ladder was going to go. And then they had a whole dewatering system inside to take that groundwater and that creek seepage, and they had some holding ponds off to the side that they were taking that water to. So they were really trying to keep their work area as dry as possible and prevent turbidity in the river. That's what it looks like today. So that's that same area. That's that fish ladder. I would actually go here. I think it's the Mirabel fish ladder. This is really, really cool. You go in there and you can actually walk down at water level. There's a big glass, glass or plexiglass, it must be glass, screen that you can actually look and see fish coming up the fish ladder. It's really, really cool. So I would highly recommend to go there. So 10:48. But I kind of want to flash back at what that looked like during construction. There's that sheet pile cofferdam, and then getting started on the concrete work in there. And see the side slope's all vegetated. Really, really awesome. I think that was some netting and some hydro seed and some fiber rolls. And then boom, there's that fish ladder. So definitely not wanting to get any turbidity into the Russian River. So that was a really awesome job. But anyway, that's just some things I have. If you guys have any questions, definitely open it up to questions. I don't have the chat though.
We do. We have quite a few questions I can field to you. Megan is asking, what are some BMPs you would recommend if an exceedance is observed? Does every exceedance need a notice of violation report, or if it is addressed, can it be described in the Type 8 monthly and annual reports?
Ooh, very good question. Usually there is, Caltrans especially, they're going to require an exceedance letter and oftentimes a notice of discharge. So just assume that every time, like even every day that it happens, you're going to have a separate report for every day. Sometimes I have included like, okay, 3 days worth in one report. There because we were putting a diversion in and they were the same thing kind of kept happening. If you have one NTU upstream, they're putting a diversion in, you're going to have an exceedance, no matter what you do. I mean, you definitely don't want to have that exceedance, but there are times that happens. BMPs, turbidity curtains, again, try to think ahead, maybe have those in the waterway already, your turbidity curtain, gravel bags, clean gravel bags, to maybe berm off that area if you can. Gravel bags are super important. Plastic, maybe there was some slope issue that happened and you need to line something with plastic. So turbidity curtain, gravel bags, and plastic, those are always things that I do recommend. Worst case, sump pump too. Maybe you had an exceedance that got downstream and you can burn that area up and then, go suck it out with that sump pump. Put it in a grassy area, that water, or put it into your water truck, or, bigger systems, maybe you had that Baker tank, but a sump pump, that's another BMP, that's very handy.
Awesome. And I have another question here. Do turbidity curtains have any impact, like entrapment, on aquatic organisms?
Um, yes, they can. In fact, there's some really good guidance I could dig up on when and how to use turbidity curtains. Generally, you don't want to have the bottom going all the way to the bottom of your channel. You want to have at least a foot off the channel, and you can get a turbidity curtain of different lengths or depths, so that you can be careful of that, because yes, you can trap aquatic organisms. So you want to have at least a foot off the bottom of any channel so that fish and organisms can get through. And then maybe your biologist is there monitoring it daily too, making sure that nothing's getting trapped in there. I don't really have issues with the turbidity curtains so much. It's mostly just maybe fish getting trapped within your diversion area initially that the biologists are trying to help clear out.
Awesome. And this one's kind of a two-parter. From Henry, were you able to use the same water from the creek to refill the bladder dam? And then from Mel, is it okay to put that same water back into the creek from the bladder, or is it waste?
Ooh, that's a good one. In those cases, I don't think that they were able to use the creek water to fill the bladder dam, although I don't remember. So I really wish I could answer that question. I don't think it was. You got to be really careful with your creek water, because you can't, you can't draft water without a permit. And every drop of water in a lot of these creeks is in, someone's got an entitlement for it. So you don't want to get in trouble there. So you definitely got to check whether you're allowed to use that or not. I mean, I think obviously it's probably best, because that's going to be, the cleanest water you can find. You're not going to have chlorine or anything in it. But I wish I could answer that question, because I don't remember what they were allowed to use in that bladder dam that I showed you prior. But I definitely know that once you do have that water in there, and it's sitting in there and it's getting hot, and who knows, if you had some kind of biologic that's now, festering in there and proliferating, it's definitely hot too. So when you get rid of that water, you don't want that water going back into the creek. That should be going to some upland area and into vegetation, ideally, if you can, or put it in a water truck and figure out a better way to dispose of it. But definitely once it's in that bladder dam, I would not want that going back in the creek.
Awesome, thank you. And then I have another one here from Dan. Do you have any recommendations for when restoring a levee and the crews are installing riprap from the barge? Making turbidity
Ooh.
hard to use because barges and tugboats are constantly bringing in more riprap.
Yeah, that is a hard one. I think I'd have to look at it case by case because um turbidity curtains can help, but if your water is slow moving and we had that case, that picture before Lindsay Slough where they had the turbidity curtain on the side channel, that did help. Generally, you don't want to have a turbidity curtain going across the channel. That's probably not going to do that much anyway, but you could in certain cases. Maybe it's going to take multiple turbidity curtains. Other than that, it's also working slow. Sometimes when you're digging for the riprap or you're placing the riprap, trying to do it in a slow manner is definitely going to keep that plume down. Um, I know sometimes you just got to dump the rock in, and there's probably no good way of doing it, but anyway, just slowing work when you can, that can help too. So I really have to have a kind of a picture and kind of site specific, kind of give better recommendations. But sometimes it is very hard to do that work without creating turbidity.
Awesome. And then from Eric, what is scour protection?
Oh, okay. So that's like you have dewatering or even out of your diversion pipe. Sometimes, you're putting water in a smaller pipe and it's going to come out faster because you're trying to squeeze that same flow out. So scour protection is just something downstream, either of your dewatering effluent or even your pipe diversion that's gonna help. That could be a riprap. That could be some gravel bags. It really depends on your flow, but that's what that is. So usually maybe you want to plan for, looking at your rockiest area. If you're putting water back in the creek, maybe your diversion is ending where it's really rocky, so that it will have some velocity dissipation.
Awesome. And I have another one here, also from Eric. For multi-level turbidity curtains, where do you sample?
Downstream, the furthest downstream. Yep. And look at your 401 permit and also your Caltrans spec. It'll tell you where they want you to sample. 401 permit, it might be 300 feet downstream, so you're going to be way downstream of your cofferdams anyway, and your turbidity curtains. But yeah, definitely downstream at the furthest downstream turbidity curtain. So yeah, good question.
Awesome. Do you have a slide with your contact information on it that you can post for
Oh crap.
everybody?
Oh, I do. Yep. Oh, my email. Sorry. Um, so- sorry, my email is robin@tullygroup.com, but I don't know if Gabriella can get you that, but it's Robin, ROBIN, @tullygroup.com. I think we're doing, yeah, 10:57.
Awesome. So thank you, Robin, for a really great presentation. I know I've certainly learned a lot. And thank you everybody else for coming out and joining us for Stormwater Awareness Week. So yeah, thank you again, everybody. And thank you again, Robin, for presenting with us this year. Yeah, thank you so much.
All right, good luck out there, guys. Thanks a lot.